This 5.7 questions number 1. Find the sum of each of the following. So to find the sum of a geometric progression, so we're going to refer to this formula. So questions A. From these geometric progressions, the first term, which is the A, is equal to 0.02. And for the R, which is the common ratio, I'm going to use 0.04 divided by the previous term, which is 0.02. So the R is 2. So these geometric progressions, you are multiplying 2 to the previous term. Now, as the R is more than 1, so to find the sum until the 12 terms, so I'm going to use the formula which I label as B here. So the sum of the 12th term will be 0.02 bracket. So the R will be 2 to the power of 12 minus 1 and divide by 2 minus 1. So solve this using a calculator and the sum of the 12 terms will be 81.9. Questions B. For these geometric progressions, the first term, which is the A, is equal to P. And the common ratio R, I'm going to use the term P cubed divided by the previous term, which is the P. So the common ratio will be P squared. So this geometric progression is formed by multiplying the previous term with P squared. Now we want to find the sum of these geometric progressions until the terms P to the power of 21. Therefore, we need to know this P21 is which terms for this geometric progression. So here I'm going to label it as the nth term. So here we're going to find the n. So we're going to solve this using the formula Tn equal to Arn minus 1. So for the questions B, the terms P21 is the Tn. So the A for this geometric progression is the P. And the R, which is the common ratio, is the P squared. So the power will be n minus 1. So this is equal to P21. So for this power here, I'm going to multiply it and I'm going to move this P to the right hand side. So it will be P to the power of 2n minus 2 equal to P20 to the power of 21 divided by P. So on the right hand side, using the law of indices, as they are of the same base, so I can just minus the power. So 21 minus 1 will equal to P to the power of 20. So now on the left hand side and the right hand side, they are of the same base, so I can just compare the power. So 2n minus 2 is equal to 20. 2n is equal to 20 plus 2, which is 22. Therefore, n is equal to 22 divided by 2, which is equal to 11. So this P21 is the 11 terms of these geometric progressions. So here we want to find the first 11 term of these geometric progressions. So it's going to be S11. So we don't use the formula B here. So the A will be the P. And the R will be the P squared. So here the n will be 11 minus 1 here over R minus 1 will be the P squared minus 1. So here just multiply this power and you're going to find that it will be P bracket P to the power of 22 minus 1 over P squared minus 1. So this will be in terms of P. Question C. So for these geometric progressions, the first term, which is the A, is equal to 1 over 2. And the common ratio, we're going to use the terms 3 over 2 divided by the previous term, which is 1 over 2. So this is the same as 3 over 2 times 2. Solve this, the common ratio is equal to 3. So this geometric progression is formed by multiplying 3 to the previous terms. As the R is greater than 1, to find the sum until the first 15 terms, then we're going to use the formula B. So S15 is equal to the a 1 over 2 bracket the r to the power of 15 minus 1 over 3 minus 1. So solve this using a calculator. You'll find that S15 is equal to 3587226.5. Questions number 2. Find the number of terms if the sum of geometric progressions 3500, 700, 140 and so on is 4368. So from the information that we have here, the A, which is the first term, is equal to 3500. The common ratio we can find using the terms 700 divided by the previous term, which is 3500. So the R is equal to 1 over 5. So here we want to find the n's. So we know that the sum of the first nth term, which is the Sn, this is equal to 4368. So to solve this, I'm going to use the formula in A as the R is less than 1. So next, we just need to substitute the information we have into the formula. So A, 3500 bracket 1 minus the R to the power of n over 1 minus 1 over 5. So this is equal to 4368. Next, I'm going to move the value of the 1 minus 1 over 5, which is 4 over 5, to the right hand side, and it will be the multiplications. So here 3500 1 minus 1 over 5 to the power of n. So when 4368 multiplied by 4 over 5, the answer will be 3494.4. So next, I'm going to move this 3500 to the right hand side. Then it will be divisions. So 1 minus 1 over 5 to the power of n equal to, so 3494.4 divided by 3500, the answer will be 624 over 625. So next, I'm going to move this negative 1 over 5 to the power of n to the right hand side so that I will get a positive 1. And 624 over 625 to the left hand side. Therefore, next I can write this as the positive 1 over 5 to the power of n equal to 1 minus 624 over 625. So the answer on the right hand side will be 1 over 625. Now this 625, we can write it as the number in base 5. So this is the same as 5 to the power of 4. Now on the right hand side, I can also write this as bracket 1 over 5 to the power of 4, as this is going to give you the same value. So now on the left hand side and the right hand side, they are of the same base, which is 1 over 5. Then we can just compare the power. Therefore, n is equal to 4. Questions number 3. A square paper is cut into 4 equal sized squares. Each portion is then cut again into 4 smaller equal sized portions. This process is repeated on each of the small portion square. So A, show that the number of square cut forms a geometric progression. So here I have a diagram of a square paper. So at first we have one square paper, so therefore it's going to be one square, just one square. Next, we want to cut this into 4 equal size square. So this is what I'm going to do. Now, so next I'm going to have 4 equal size of square. So next, for the small portions of square, we're going to cut it to another 4 like this. Therefore, next, in total, we're going to have 16 square, and so on. So we want to show that the number of square cuts form a geometric progressions. Therefore, we can prove it by using the R, which is the common ratio. So here, the first ratio here, we're going to use the terms 4 divided by the previous term, which is 1. The answer will be 4. And if we continue to use the other consecutive term, which is 16 divided by the previous term 4, you'll find that the ratio is 4 as well. So when you are having the same ratio, which is the common ratio, R1 is equal to R2, therefore the number of square formed here will form a geometric progression. Questions B. Find the total square obtained if the process is repeated for 6 times. So total square, we're going to sum up all the number of square. So it's repeated for 6 times, therefore we're going to find the square for S6. So here as the R is equal to 4, which is greater than 1, then we're going to use the formula in B. So the A will equal to 1, bracket, so R will be 4 to the power of 6 minus 1 over 4 minus 1. So solve this using a calculator, you'll find that the total one, the answer will be 1365 square. Self-practice 5.8, questions number 1. Complete the following crossword puzzle. So for the horizontal part, A, find the sums to infinity of geometric progressions 1500, 500, 166, and 2 of 3, and so on. So the formula for us to find the sum to infinity will be A over 1 minus R. So we always want to refer to this formula when we solve for the sums to infinity. So for questions A, the first term will be 1500. And for the common ratio, we can use the terms 500 divided by the previous term, which is 1500. So the R will equal to 1 over 3. So now to find the sums to infinity, so we're going to use 1500, which is the A, divide with 1 minus 1 over 3. So solve this using a calculator, you find that the answer will be 2250. So for the horizontal part here, it will be 2250. Questions B. Wilson loaned RM 15,000 to buy a motorcycle. So every year he managed to reduce 50% of his total loan. Find the maximum amounts paid by Wilson. So the loans paid by Wilson each year here will form a geometric progression. So it starts with 15,000. And as he managed to reduce 50%, so next year the total loan left will be, you're multiplying the 15,000 with 50 over 100%. In other words to say, you are multiplying with half, 1 over 2. Therefore, the next year the total loan left will be 7,500, and so on. So the questions here asking you to find the maximum amounts paid by Wilson. In other words to say, you are finding the sums to infinity of these loans paid by Wilson. So here the A will be the 15,000, and the half, 1 over 2 here, will be the common ratio. So to find the maximum amount paid, we're going to use the formula sum to infinity. So it will be 15,000 divided by 1 minus 1 over 2. Solve this, the answer will be 30,000. So the answer for the horizontal B here will be 30000. Next, vertical part, question C. Given that the sums to infinity is 4,480 and the common ratio is 1 over 2, so find the first term of these geometric progressions. So here we want to find the A, and the R, which is 1 over 2, has been given. So sums to infinity is equal to 4480. Now refer to the formula that we have here. We're going to solve for the A. So Sum to infinity is a over 1 minus r 1 over 2. So the answer of this part 1 minus 1 over 2 is 1 over 2. So move this 1 over 2 to the right hand side. It will be 4 at 0 multiply 1 over 2. Therefore, the a will equal to 2240. So for the vertical part C, it will be 2240. Vertical D, 4.818181 and so on can be written in the form of h over 11 finds the value of h. So for these questions D, I'm going to show you two methods. The first one is we're going to use the method that we learned in law of sets by changing the recurring numbers into the form of fractions. So for method number one, first, we're going to let this 4.818181 and so on as A. And for the decimal part, as this is a recurring decimals, we can label it as n. So therefore, here the n will be the 0.8181 and so on. And for the first part here, I'm going to label it as number 1. Next, the repeating part here is the add 1. So I'm going to move 2 places to the right hand side. By doing that, we are actually multiplying 100 on both sides. So 100n equal to 81.8181 and so on. So this one we're going to label it as equations number 2. Next, I'm going to use equations 2 minus equations 1. So 100n minus just 1n is going to be 99n. So 81.8181 minus the 0.8181. So the decimal parts here, as this is repeating and this is the same as, it will be cancelled. Therefore, what left will be just 81. Therefore, n is equal to 81 over 99. So this one we can simplify it by dividing it using number 9. Therefore, we're going to get 9 over 11. So here the A is equal to 4 plus 9 over 11. So this is the same as 4 and 9 over 11. So we're going to change this mixed number into the improper fractions. It will be 53 over 11. And when we compare it with h over 11, therefore the h is equal to 53. So for the vertical D, the answer will be 53. For vertical D, another method is for this 4.818181 and so on, we can split it as 4 plus 0.81 plus 0.0081 plus 0.000081 and so on. And for this decimal parts here, it's going to form a geometric progressions. So this 0.81 here will be the first terms. And as for the r, we can find the r by using 0.0081, divide it with the previous term 0.81. This is the same as 1 over 100 or 0.01. So when you multiply 0.81 with 0.01, then we're going to get the next one. So for this decimal parts here, and it is not going to end, and it is going to continue. So to find the total of it, we're going to use the formula sums to infinity. So here, it's going to be 4 plus, so for the decimal parts, the total, we're going to use the formula A, which is 0.81, divide by 1 minus R, which is 0.01. So you'll find that the answer for this part here, it will be equal to 9 over 11. Combine them together, you can get 4 and 9 over 11. Convert this to improper fractions, then you're going to get 53 over 11. And when you compare it to h over 11, then h is equal to 53. Self-practice 5.9, questions number 1. A wire is cut into a few pieces in which 10x centimeter, 4x plus 20 centimeter, and 3x minus 10 centimeter are the three consecutive pieces of a geometric progression. So A, find the longest piece if 10x is the second longest term. So this 10x is the second term, T2, and this is the second longest term, which means the term before it, which is the first term, will be the longest piece. Therefore, this longest piece is actually referred to the first term, which is the A. Now, before we are able to find the A, we need to solve for the x first. As we know that in a geometric progressions, if you divide two consecutive terms, you will get a common ratio. Using that information to find the x, I can use 4x plus 20 when I divide it with the previous term, which is 10x. The ratio here will be the same as you are using 3x minus 10 divided with the previous term, which is the 4x plus 20. So next, we are going to cross multiply this. So here you will get 4x plus 20 times 4x plus 20, which is square here, and 10x multiply 3x minus 10. So when you expand for the 4x plus 20 square here, you will get 16x square plus 160x plus 400. And on the right hand side, you will get 30x squared minus 100x. Now, the highest power of the x is a square. Therefore, this is going to form a quadratic equations. To solve this, we're going to write this in general form. And to keep my a positive, I'm going to move everything to the right hand side. So here I will get 30x squared minus 16x squared minus 100x minus 160x minus 400. Then this is equal to 0. So 30x squared minus 16x squared, you will find the answer is 14x squared. And for the x, it will be negative 260x minus 400 equal to 0. So here I can simplify every terms by dividing it with number 2. So after dividing with number 2, you will get 7x squared minus 130x minus 200. So next we're going to do the factorizations. So the first bracket you get is 7x plus 10. And the second one will be x minus 20. Therefore, x is equal to negative 10 over 7, or x is equal to 20. So now which one will be the correct answer? Now if you substitute the x negative 10 over 7, for example, into the terms t2, the 10x, you will find that the length will be in the form of negative. Therefore, for the x equal to negative 10 over 7, we will reject this answer. And the answer that we're going to accept is x equal to 20. Now, I already know the x. Therefore, the second term, which is 10x, is equal to 10 times 20, which is equal to 200. Then the third term, which is the 4x plus 20, will be 4 times 20 plus 20. This is equal to 100. So now I can find the common ratio. T3 divided by T2 100 divided by 200 is equal to 1 over 2. Now, to find for the A, I can use the T2. So I know that T2 is equal to 200 using the formula Tn, which is ARn minus 1. A, which is the longer piece that we want to find, it will be A bracket, the R will be 1 over 2. The power will be 2 minus 1. So 2 minus 1 is 1. Therefore, to move this 1 over 2 to the right hand side, the A will equal to 200 times 2. So the answer for A, the longest piece, is equal to 400 centimeter. Questions B. If the wire is cut into sums to infinity pieces, find the maximum length of the wire in meter. So from questions A, we already find the longer piece, which is the A, is equal to 400 centimeter. And the R is equal to 1 over 2. So to find the sum to infinity, using the formula A over 1 minus R, we already have all the informations we needed. So A is 400 divided by 1 minus 1 over 2. Solve this using your calculator, you'll find that this is equal to 800 centimeter. And the answer, and the questions B want the answer in meter. Therefore, 800 centimeter is equal to 8 meter. Questions number 2. The diagram on the right shows the patterns of a spider web. The perimeter of each semicircle follows geometric progressions with the smallest radius r centimeter and each subsequent radius increase 40%. So A, form the first three terms for the perimeter of the semicircle in terms of r. So to find the perimeter of the semicircle, this is the same as the circumference of the circle and you divide it by 2. It will be 2 pi r divided by 2, which is equal to pi r. So to form the first three terms, so the radius is the r centimeter. So for the first term, it hasn't increased by 40% yet. So for the first terms, the T1, it will be just pi r. And as for the second terms, it will be increased 40% compared to the previous one. So for the second term, so we're going to take the first term, the pi r, and then we're going to multiply it with 140 over 100. So this is the same as you are multiplying it with 1.4. So this will be the second term, or we can write it as 1.4 pi r. And as for the third term, it will be increased 40% compared to the previous one, which is the T2. So it will be 1.4 pi r. You multiply it with 140 over 100. So this will be 1.4 pi r multiply 1.4. Therefore, you're going to get 1.4 square pi r. So the first three terms is the pi r, 1.4 pi r, and 1.4 square pi r. Questions B. Find the total length of semicircle in meter if the spider web has 15 semicircles and each radius is 2 centimeter. So from the questions A, we know that the first term T1 is equal to the pi r. Now the radius, we know that this is equal to 2. So the first terms will equal to 2 pi. And from the questions A, we know that you are multiplying 1.4 to the previous terms. Therefore, this 1.4 will be the common ratio. So to find the total length of the spider web that has 15 semicircles, therefore we're going to find the S15. So we can refer to this formula to find the S15 as the R here is greater than 1. So S15 equal to the A, which is 2 pi, bracket the R 1.4, so the N here will be 15 minus 1 over 1.4 minus 1. So solve this using your calculator. The answer will be 2427.94 centimeter. But the questions B here asking you to state the answer in meter. Therefore, we're going to divide this centimeter here with 100. So we're going to move 2 places toward the left hand side. Therefore, it will be 24.28 centimeter if we just take into 2 decimal places.